Hello everyone, my name is Prem Kumar Mehta. My meeting number is 23B0222. Today I want to present about mathematics discrete implement in network. First of all, I explain about what is network. Network is a group of interconnected devices or systems that can be communicated and share resources with each other. These devices can include computers, servers, phones, and other hardware, and all linked by various communication methods such as cables, Wi-Fi, other wireless connection. Now I explain about how network implement in real life and mathematics discrete. First of all, network can be physical like with switch and cables or social media also, such as Facebook, Twitter, Instagram. This project can interpret network and discrete method. This project aims to explore how to discrete mathematics can be applied to the design, analysis, and optimizing of networks. Discrete mathematics provide tools and methods such as graph theory and combinatorics that are essential for understanding network structure, improving network efficiency, and solving network-related problems. The project will investigate these mathematical techniques to enhance network performance and reliability. The main goal is to understand how concept and technique from discrete mathematics can improve in network performance, reliability, and adaptability. This involves using mathematical methods to enhance the efficiency, stability, and flexibility of networks.
Hi, my name is Mura Alisa Alaina binti Muhammad Nasir, metric number S23A0144. I want to explain about the application of discrete math in network. First, for the adjacency metric is a square metric used to represent a finite graph. Each element aij indicate whether there is an edges between node I and j. The features, the corner element aii are 0, indicating no edges connecting a node to itself. Aij is 1 if there is an edges between node I and j, and 0 if there is no edges. White graph, each metric element aij can have a real value representing the strength and width of the edges. For example, internet backward can be weighted to represent data flow or backward capacity. In social network, what can represent the frequency of interaction between actors. Unweighted network is represent basic on-off connection between nodes. Weighted network represent connection with specific strength or value, providing more information about the relationship between nodes. A directed network, the graph, has edges with a specific direction pointing from one vertex to another. Example, World Wide Web hyperlink run in one direction. Food webs energy flows from prey to predator. Citizen network, citizen point from one paper to another. Here I include a graph image. The graph is a directed graph consisting of 10 nodes vertices and some directed edges. Each edges is represented by a label aij, where edges point from node j to the node I. The adjacency metric of this graph is asymmetric because the direction of edges is not necessarily two-way between two nodes. For example, if there is an edges from node 1 to node 2, represented by a to 1, this does not mean that there is an edges from node 2 to node 1.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhanisa binti Muhammad Tamizi, and today I will present on possible risks or possible problems. For the first one is inefficient network representation and analysis. Without discrete mathematics, representing and analyzing network would lack a systematic and efficient approach. The adjacency metric, a fundamental tool in graph theory, captures the presence or absence of edges between nodes, which is crucial for understanding network structure. With such as a representation, identifying important network properties such as connectivity, clustering, and shortest path become challenging because these properties rely on precise and clear representation of the network provided by the adjacency metric. The second problem is mismanagement of weak network. In network, where connections have different strength, called weak network, discrete mathematics help manage this strength efficiently. If weak are handled incorrectly, it can cause big problems. For instance, in communication network, if we don't calculate the capacity of connection properly, we might waste resource or overload the network.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Samir Muhammad Qasim Kadira. My meeting number is S23A0097. Today I will talk about probe accurative improvement. So I give two solutions. Solution one, to improve to make network analyze better using discrete mathematics, we can use machine learning by looking at past network data. Machine learning can predict future traffic, find poten- potential problems, and suggest fixes before a source arise. This help this helps manage network resources better, reduce reduces downtime, and makes the network run more smoothly. Solution 2, to improve network analyze with discrete mathematics, we can create an automatic monitoring system. This system uses math to keep track of network performance, performance and, 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 spot, and spot problems in real time. By using graph theory and other math methods, it can find unusual patterns or issues. The conclusion of discrete mathematics theoretical proves surprising relevant in the real world. The internet, for instance, relies on a network of routers to transmit information across vast distance. Social media platforms function as networks where users are connected through following or friending features. We can handle issue with the network routering, error detection, and data transmission efficiency while maintaining resilience and dependability thanks to the theoretical framework given by discrete mathematics. Linking framework plan will make activity blockage more common and social network research will be less valuable, making it more troublesome to recognize important influence and can it communicative dynamic. These are just a few examples of how network theory adopted is discrete mathematics help us understand and optimize the system that shape in our world. Thank you.